basic concepts of chemistry. This is part 4. In this video, we are going to discuss about the laws of chemical combination. Laws of chemical combination. Students, generally we know atoms are unstable because they have high energy. So atoms will combine to form molecules. While they are combining to form molecules, they will lose their energy and get the stability. When atoms combine to form a compounds, they will obey certain laws. Those are known as laws of chemical combination. When atoms combine to form molecules or compounds, they will follow certain laws. These are known as laws of chemical combination. First law is law of conservation of mass. Law of conservation of mass. This has been proposed by Anthony Lavoisier. He is known as father of modern chemistry. Law of conservation of mass is proposed by Anthony Lavoisier, which is known as a father of modern chemistry, which says that in a chemical reaction, total mass of the products is same as total mass of the reactants. Total mass of the products is same as the total mass of the reactants. So for example, when you take thermal decomposition of calcium carbonate, assume this is 10 grams. 10 grams of calcium carbonate on heating, giving CaO of 5.6 grams. Then the weight of CO2 formed is 4.4 grams. That means the total mass of the products 5.6 plus 4.4, which is same as the total mass of the reactants. This is known as law of conservation of mass. We can also state like this: mass neither be created nor destroyed. Total mass of the universe is conserved. That is known as law of conservation of mass. But for a chemical reaction, total mass of the products is same as the total mass of the reactants. By studying many combustion reactions, Lavoisier proposed law of conservation of mass. Right? Then this law cannot be applicable to nuclear reactions. Cannot be applicable to nuclear reactions. After discovery of radioactivity in nuclear reactions, this is disproved. But in balancing the chemical equations, we use law of conservation of mass. Law of conservation of mass. Next law is law of definite proportion. Students, second law is in the laws of chemical combination. Second law is law of definite proportions, also known as fixed proportions or constant proportions. Law of definite or fixed or constant proportions. When two different elements combine to form a compound, they will combine in fixed ratio by mass. They will combine in fixed ratio by mass. Fixed ratio by mass. Students, for example, carbon and oxygen, they are combining to form CO2 gas. Carbon and oxygen, they are combining to form CO2 gas. Whatever the process of synthesis of CO2. So we know burning of carbon will complete combustion will give us a CO2 gas. Any hydrocarbon like CH4, the combustion of hydrocarbon will give us CO2 as well as H2O. Whatever the process of synthesis, one process is combustion of carbon will give CO2, combustion of hydrocarbons will give CO2, metal carbonate reaction with the dilute mineral acids will give metal salt plus carbon dioxide gas plus H2O. Whatever the process of synthesis of CO2, the mass ratio of carbon and oxygen, CO2 you take, carbon atomic mass is 12. Only one carbon atom it is present in the one molecule of CO2. So 12 is 2. For oxygen, atomic mass is 16. For 2 oxygens it is 32. What is the simplest ratio? 4 3s are 4 8s are. So the mass ratio of carbon and oxygen in the CO2, it is a fixed 3:8. Whatever the process of synthesis of CO2, the mass ratio of carbon and oxygen, if they are forming carbon dioxide, then it is always fixed, that is a 3:8. This law of multiple proportions. Law of multiple proportions. When two different elements combine to form more than one compound, the masses of one element which combines with fixed mass of other element will be in whole number ratio. So students, law of multiple proportion, which says that when two different elements combine to form more than one compound, the masses of one element which combines with the fixed mass of other element will be in whole number ratio. For example, carbon is forming two different oxides, carbon dioxide, carbon monoxide. Carbon monoxide is CO, carbon dioxide is CO2. Here the carbon, only one carbon is present, only one carbon CO, one carbon in CO2. Then the mass of C, atomic mass of C is 12, oxygen is 16. Here atomic mass of carbon is 12, oxygen is 16 into 2 is 32. So here simplest ratio, 4 3s are 4 4s are, right? 4 is to 3 is to 4. Here 4 3s are 4 8s are. So here if we take the mass ratios of oxygen, that is 16 is to 32, which is combining the masses of oxygens which are combining with the fixed mass of other element. Carbon mass is fixed here, one carbon atom in the both the compounds. Then the mass ratio of oxygens will be in the whole number ratio, that is 16 is to 32, which is a 1 is to 2, which is known as law of multiple proportions. Some other examples we can take like CuO, Cu2O, this set of two compounds will illustrate law of multiple proportions. Nitrogen gas, nitric oxide, nitrous oxide, nitrogen dioxide, nitrogen trioxide, nitrogen pentoxide, all these will obey law of multiple proportions. So the compound should contain, the set of compounds should contain same elements in the different ratio. For example, students, two samples of gases it is given. Assume one is A, other is B. Two gases samples is given. One is A, other one is B. Other one is B. Both are containing same element. Let us assume that this will contains X element and Y element. Not formula is XY. This gas A, this is gas in the one container, one sample. It is not gas A, it is one sample here. A, B, two samples of gases is given. Assume these gases, the gas is it is present in the container A, it is made up of two different elements XY. B also made with the same elements XY. For example, if you measure this mass ratio here, X is to Y, if we are getting it as a 1 is to 2, and here also if you measure the mass ratios, if it is the same, that means that is obeying law of fixed proportions. Both the gases which are present in the containers is same. For example, if in the sample A, the mass ratio of X and Y we are getting 1 is to 2. But assume that B sample, mass ratio of X and Y we are getting it as a 1 is to 3. So that means fixed mass of one element is combining with the variable mass of other element, which will bear integer ratio, whole number ratio. That is known as law of multiple proportions. Law of multiple proportions. Right? Next law we will discuss. Students, next law is law of reciprocal proportions. Law of reciprocal proportions. Which says that masses of two elements mass ratio, mass ratio of two elements A and B, which combines with combine with fixed mass of other element C, either same or simple multiple of proportions of masses when A and B directly combining to form a new compound. Here, law of reciprocal proportions will say that mass ratio of two elements A and B, which combine with the fixed mass of other element C, either same or simple multiple of proportions of masses when A, B directly combining to form a new compound. We will take one example. Three elements we are considering: carbon, hydrogen, oxygen. Right? Then we will take a compound for carbon and hydrogen as CH4, carbon and oxygen as CO2, and for H and O is H2O. Right? So in these two compounds, students, in this carbon hydrogen compound CH4, carbon oxygen compound SCO2, the mass of the carbon is fixed. One carbon it is present. If we take the ratio hydrogen and oxygen mass ratios, if we take, so hydrogen is 2, hydrogen is 1 into 4 is 4. Right? For oxygen is 32. The simplest ratio we are getting 1 is to 8. Okay. So here, what is the mass ratios of hydrogen and oxygen which are combining with the fixed mass of the other element C? This here it is C, carbon. Okay, hydrogen and oxygen are combining with the fixed mass of the other element C. The mass ratio of hydrogen and oxygen is, we are getting 1 is to 8. When they are separately forming a new compound, in this compound, water, we will check the mass ratios. Hydrogen to oxygen, so hydrogen is H2, it is 2, and oxygen is 16. The simplest ratio we are getting, it is the same, 1 is to 8, 1 is to 8. So this is known as law of reciprocal proportions. Students, next law is Gay-Lussac's law. Gay-Lussac's law. In a chemical reaction, gaseous reactants or products will do so in whole number ratio by volume when all the gases are measured are measured at similar conditions. Similar conditions. Students, for example, you take H2 gas combines with the Cl2 gas, which gives 2HCl gas. 1 mole of H2 is combining with the 1 mole of Cl2, which gives 2 moles of HCl. If we consider it is for an STP condition, 1 mole of H2 is 22.4 liters. Cl2 is 22.4. So HCl 2 moles it is a 44.8 liters. When we take this ratio, this will be whole number ratio, 1:1:2 we are getting, right? In a chemical reaction, gases, reactants are products which will do so in whole number ratio by volume when all the gases are measured at similar conditions, right? Here the volume ratio we are getting it as a whole number. This is known as Gay-Lussac's law. Next we will discuss about Avogadro's law. Students, next law is Avogadro's law. Avogadro's law, which says that equal volumes of all gases contains equal number of molecules when they are measured at similar conditions. When they are measured at similar conditions of temperature and pressure. Similar conditions of temperature and pressure. Students, for example, let us consider H2 gas is present in a container. H2 gas is present in a container. The volume is 1 liter. 1 liter volume it is present, measured at STP condition. For example, if this gas has N molecules, capital N molecules, then you take another gas with a different atomicity we will take, that is SO3 gas we will take. SO3 gas, which is also 1 liter, STP condition, similar conditions of temperature and pressure we are considering. Here atomicity of H2 is 2, diatomic gas. SO3 is tetraatomic gas. 1 liter of each gas is there. If the number of molecules in the H2 is N, number of molecules of SO3 in 1 liter, that is also same, N molecules. N molecules only. But atoms it is different. Molecules only it is same. In another words, it can be told as Avogadro's law. 1 mole of any gas at STP condition, at STP occupies 22.4 liters of volume. Students, this is all about laws of chemical combination. Thanks for watching.